As we evaluate limits, remember that a limit exists only when the function values approach one specific real number as x gets closer to a single point. So if the function values do not approach a single value, then the limit does not exist. And this example here, this graph of sine of 1 over x, is an example of when a limit doesn't exist. Looking at this table, I have, here's my function, the sine of 1 over x. This is similar to the previous example. Please keep in mind that they're different. When you first look at it, it may seem like it's the same, but the previous example was sine x over x. That's different than sine of 1 over x. And this limit as x approaches 0 was 1. And this is a very famous limit that you'll see pop up frequently throughout the class. Now for this new example, for the function sine of 1 over x, as x approaches 0, coming from the left, notice that the values are not approaching any specific number. And in fact, they're bouncing between positive and negative numbers. So you don't see a pattern of where it's approaching a specific value. And the same thing happens as you're approaching from the right. This was from the left. As you're approaching from the right, as the values get closer and closer to 0, the same thing happens. You're bouncing back and forth between negative and positive numbers, and there's no real pattern to where you can see a clear-cut answer where you're approaching a specific value. And if you look at the graph of sine of 1 over x that I just boxed in here, what happens as you're coming in from the left and the right, the graph is bouncing back and up and oscillating between -1 and 1. So, and as you get closer and closer to 0, that never stops. I could zoom in closer and I would see the same picture over and over and over again. No matter how close or how far I zoom in, I'm going to see that function bouncing back and forth. So we're never actually going to approach a single value. So this is an example where the limit does not exist because it is not approaching a single value.